All right, so today we're looking at characteristics of an erosional and depositional system. All right, so earlier in the year, I did a little demonstration with the golf ball, and it said that if I was holding the golf ball right there, it really doesn't have any kinetic energy because it's not moving, but it has a lot of potential energy because if I take my hand away, the ball will start moving. All right, so right here, no kinetic, lots of potential, but as it's falling, what's happening is it's going faster and faster on the way down, so it's gaining kinetic, but it's running out of room to fall, so it's losing potential. Now, with a stream, pretty much the same thing's happening. A stream flows downhill, just like me dropping a ball. At the beginning, or the source of the stream, this is where the stream has the most amount of potential energy. So maximum potential energy at the source. And as the water is flowing downhill, that's like the golf ball dropping. It's going to go faster, it's going to gain kinetic, but it's running out of room to fall, so it's losing potential. So as it's going down the side here, the potential energy turns into kinetic energy as the stream flows towards the end. But then once it gets towards the ocean here, it's like the brakes are applied to it, and the stream basically stops down here and then loses its kinetic down here, and then you get a bunch of deposition. But as it's flowing downstream here, the potential is turning into kinetic and it has the most potential up top here. Now, this is like a side view. Here's like a top view of what's going on. And so let's say the stream's not just going in a straight line towards the ocean, rather it has a couple bends in it. All right. Now, when it goes around a bend, you should remember that when it goes around a bend, on the outside of the bend, the water goes faster, and then on the inside of the bend, the water goes slower. Right? Well, on the outside of the bend, if it's going faster, I'm going to have more erosion there. But also, if the water is going faster, that means it has a lot of kinetic energy. So on the outside of a bend, high kinetic energy equals erosion. The faster the water goes, the more kinetic energy it has, the more erosion there is. On the inside of the bend, like right there, the water slows down, meaning it has less kinetic energy. And when it slows down, you get deposition. So low kinetic energy equals deposition. On the inside of the bend, it slows down and it loses energy, so it dumps material there. So erosion on the outside of bends, deposition on the inside of bends. And then now where the water goes fastest in the stream is typically where it's the deepest. So in a straightaway over here, if I was going to do a profile what the stream looks like, it typically would be something more like that, where it's going to be fastest in the middle because that's where the water is going fastest. When it goes around a bend like that, it's going fastest on the outside. So if I were to do a profile what the stream looks like that, then it would look kind of like this, where the deeper part is over here, the outside part, because of the erosion, and then it's shallower on the inside part here because of the deposition. And the same thing holds true here. If I was doing a profile along that line right there, it would look something like that, where it's deeper over here because of the erosion, and then shallower over here because of the deposition. Okay. Now, when the stream enters into the ocean or a lake or something like that, again, it's like the brakes are put on it. So you get a whole bunch of deposition taking place right there where it enters into the larger body of water. And that feature that forms there is this kind of fan-shaped feature, or sometimes called a triangular feature. And the name for that is a delta. So a delta is where a river or stream dumps a bunch of material when it enters into a larger body of water. Now, like right here, that's where it's mostly deposition taking place there with not much erosion. Over here, mostly erosion taking place with not much deposition. Now, if I was to walk across it from here to there, so again, here's where the most deposition is taking place, as I'm going this way, I'm going to have less and less deposition. My deposition is going to decrease, but my erosion is going to increase. So somewhere in the middle there is going to be a spot where the amount of erosion and deposition is equal to each other. All right? So again, erosion is when the material moves to a new location. Deposition is when stuff gets dumped there. So if the stuff moving away is equal to the stuff that's being dumped there, then at that particular location, the amount of material is going to be balanced. The amount that you're losing and gaining is going to be equal to each other, so it's going to balance out. Now, the word we use for that is something we talked about earlier in the year. When you have changes taking place, but they kind of cancel each other out, you have changes on a small scale, but the overall situation stays the same. That's a term that we used earlier in the year. We call that a dynamic equilibrium. So in like a river system or something like that, where if I have a spot where erosion, the amount of erosion is equal to the amount of deposition, then overall I have the same amount of material. And I'm in a dynamic equilibrium. Changes taking place, but overall the situation stays the same. Now, how streams change over time. All right. Now, I've mentioned before that streams carve out V-shaped valleys, but they don't keep that V-shaped valley forever. Streams only have really V-shaped valleys when they're relatively young. And we call it the youthful stage of a stream, when it has a very narrow V shape to it. Now, in the youthful stage of a stream, not only do streams have V shapes to them, but for the most part, the water travels pretty much in a straight line. You know, there may be a couple bends here or there, but for the most part, it's in a pretty straight line. And the reason for that is in a youthful stage, there is a pretty large gradient. So in other words, it's pretty steep, right? Now, a lot of times you won't necessarily see, at an angle like that. What you might see instead to show you that there's a big gradient is a bunch of waterfalls. Because each time there's a waterfall, it's a big drop off. So if you see a lot of waterfalls, it tells you that you normally have a big gradient. Right? Now, like a gorge would be a good example of a very young stream channel. Now, as time goes by, what happens to the stream is that chunks of rock break off there, fall in, get carried away. Chunks of rock from there break off, fall in, get carried away. More chunks of rock break off, get carried away. More chunks of rock break off, get carried away. So what started off as a very narrow V, because of erosion, as time goes by, the V is going to get wider and wider and wider and flatter. So you go from a youthful stage to a mature stage of a stream. Now, the main things that are going to happen as a stream gets older is one, the valley is going to get a lot wider. So here the valley was really narrow. As time goes by and the V gets wider and wider and wider, the valley is very broad now. Right? Another thing, in the youthful stage, the stream is pretty much going in a straight line. Now, the stream kind of zigzags back and forth. And the word we use for that when the stream zigzags back and forth is we say the stream meanders. So meander means to bend around like that. Right? Now the reason why it meanders is because the gradient has changed. When the stream was youthful, it had a very steep gradient, but again, as the older it gets and the more erosion takes place, it gets flatter and flatter and flatter. So in a mature stage, there's a very small gradient. In other words, the land's pretty flat. And it's because of the small gradient that the stream kind of meanders back and forth. Right? And another feature you'll notice in a mature stage is you have a bunch of these little, they kind of look like horseshoe-shaped things. Those are called oxbow lakes. Right? It's a special type of lake that you only see in areas that have meandering streams. Right? So that tells you right off the bat that you have a mature stream valley. Now, how the oxbow lakes form is, I'll start off with a river that looks like this. So it has some meanders in it. Let's say the water's flowing that way. And what we know from back here is that you get the most amount of erosion on the outside of a bend. So if the water's going like that, I'm going to have more erosion there, so it's going to eat back. And right there, I'm going to get a bunch of erosion, so it's going to eat back like that. Then as time goes by, more erosion is going to happen, and that'll eat back like that. And then more erosion yet. And that's going to eat back like that. And then this will eat back some more, this will eat back some more, and pretty soon, what you have is something where the river is doing that, all right? So for a little while, you have an island right there, all right? But it actually doesn't stay an island very long because water is basically lazy, all right? The water wants to go take the shortest route, basically. So most of this water is going to go straight through with only a small fraction of the water going around that bend, all right? It really has to do with gradient. There's a steeper gradient here and a lower gradient there, but anyway, since most of the water is going this way and only a fraction of the water is now going around the bend, that if there's less stream discharge, then the stream is going to be going slower as it goes through there. And if it slows down, then you're going to get deposition. So it's going fast and then it slows down. So right here, you get a whole bunch of deposition and you end up with some like deposition down here too. So eventually you get more and more and more sediment gets deposited right here. And that cuts this off from the rest of the river, all right? And as more and more stuff gets deposited there, that basically just becomes land now, all right? So this is just going straight, and this gets cut off like that. So that feature right there is now an oxbow lake, right? Now it still has water in it, but it's kind of cut off from the river. And geologically speaking, oxbow lakes don't last that long. Because what happens is time goes by, they start to like get cattails growing in them, and then it'll kind of turn into more of a swamp than a lake, and then eventually just kind of fills in as time goes by. But for a while, you have these little horseshoe-shaped lakes over here. All right. Now, a couple real short YouTube videos I want to show you. It shows you a delta forming, and it also shows you how a stream channel changes. So, all right. All right, so this feature here, what this is called stream table. And it's like a long like table thing. It's kind of like a long, like a real long and really shallow, like imagine like a fish tank kind of thing. Or like a really, really big baking pan. However, this it is right there. You put a bunch of sand in it, and if you let water, you hold it at an angle and you let water go through it, the water kind of acts like it would in an actual river. So that's what this feature is. So over here is like the ocean. Here's the river, and this video is fairly short, but you'll see the delta forming over here as time goes by. So you see as the water is going into the larger, as the moving water enters into the larger body of water, you're getting stuff getting deposited there. So there's your delta forming right there. All right, so they do it again, this time with some more sediment here. And you'll see actual better delta form here in a minute. Now, the size of deltas that get formed depend on a few things, one of which is how much sediment is being carried by the river, because some rivers carry more sediment than other rivers do. And this one, they put some more sediment in the river, so you see that there's a much more profound delta forming here. And notice the general shape of this is kind of like that fan shape that we were talking about a little while ago. All right. So that is how a delta forms right there. All right, so another video I want to show you really quick is one that shows you how the stream channel creates like cutoffs in oxbow lakes. All right, so this is another stream table set up, and it has with some sand. But you can see as the river's bending, going around the bends here, that it's eating away some areas better than other areas here. So you can see like right there, it's eating back. And we'll watch this for a little bit. And you'll see some cutoffs, and so it's starting to cut through right there. All right, so now most of the water is going this way. This part that used to be the river, that would be where an oxbow lake forms now. All right, so that would be an oxbow lake. And up here, you'll eventually see that this will cut through, and that leaves that section right there. So most of the water is going right there, so that'd be an oxbow lake as well. So this is only a stream table, but rivers basically do the same thing in real life as well. All right? So if you see lots of meanders and then some oxbow lakes, you know it's a mature river valley. All right.